Let's find the derivative using the quotient rule. The quotient rule says if you want to find the derivative of a function divided by a function, 3 minus x squared over 4 plus x plus 2x squared, you can do so by taking the derivative of the top times the bottom minus the top times the derivative of the bottom all over the denominator squared. So I have my low function times the derivative of the high function, low d high, minus the high function times the derivative of low, low d high, minus high d low, square the bottom, and away we go. So let's take a look at the derivative of 3 minus x squared over 4 plus x plus 2x squared. First off, the denominator is going to be that current denominator that you have, that g of x, that 4 plus x plus 2x squared. And you're going to take that expression and square it. Now, I'm not worried about simplifying here. I just want to find the derivative. On the numerator, it says take the derivative of the top, take the derivative of f. So I'm going to have the derivative of 3 minus x squared, that was the top, times my bottom function. The bottom function was at 4 plus x plus 2x squared. And I'm going to subtract from this the top function, leaving it alone, keeping it as an f of x. So that's a 3 minus x squared times the derivative of the bottom function. So times the derivative of 4 plus x plus 2x squared. If I take the derivative of 3 is a constant, so that's 0. If I take the derivative of negative x squared, that 2 drops down, that becomes a negative 2x as my first derivative. All these other pieces are just floating down for the ride here. I've got another derivative to take. So I've got the derivative of 4. That's 0, so I'll just leave that out there. The derivative of x with respect to x, that's 1. The derivative of 2x squared, that 2 drops down, that gives me 2 times 2, or 4x. Used to have a power of 2, and now has a power of 1. So I've taken the derivative of f, I multiplied it by g, and I've taken my starting function and leaving it alone, and I multiplied that by the denominator derivative, that g prime of x. And this is all over that g of x quantity squared in the denominator. So that's where each of these pieces are coming from. The derivative is messy. We could simplify that if we wanted to, but it still works for plugging in and finding values. So the quotient rule might not give me the cleanest derivative, but it did give me the derivative here in 2 steps, which is pretty nice. So the product and the quotient rule do give me some fast derivatives, even if those derivatives do end up being a bit messy sometimes.